You're welcome back to this channel. In today's class, I want to explain eigenvalues and eigenvectors, then how we can find them. If you could remember, when we were doing sets of linear equations, where we used matrix method, determinant method, which is also known as Cramer's rule, and Gaussian elimination method. We used to write those equations in matrix form, where we will later say that we represent them by AX is equal to B. So here, this is matrix A. So what this means is that every square matrix is associated with a special vector. This is special in the case that if you multiply this square matrix by this vector, you always have, well, the line, this is a column vector. The answer you are still going to get will still be column. The main matrix is a square matrix, and its special vector is what? A column vector, or you say that a column matrix. And at the end of the day, after multiplying it, you are still going to get what? A column matrix. So that is why this vector is special to this square matrix. So now we can now write this our B to be equal to a constant multiplied by this vector matrix, this vector X. So let's name this one equation 1. So that means our equation 1 becomes AX is equal to lambda X. So from here, if we multiply I, that is identity matrix, this is an identity matrix. If you multiply identity matrix by the right hand side here, we have AX is equal to lambda XI. Identity matrix, if you multiply it by any matrix, you are still going to get that matrix back. So this is an identity matrix. But in this case, the order of identity matrix A can only be determined by the order of this matrix A. If here is 2 by 2 matrix, that means our identity matrix that we're going to multiply will also be 2 by 2 matrix. If matrix A is order 3 by 3 matrix, that means identity matrix will also be what? 3 by 3 matrix. So from here, we can say that we have AX minus lambda X I is equal to 0. There's no magic here. So X is common. Let's factorize X out. So I have A minus lambda I and X is equal to 0. So here, our X is what? I told you it's a special vector. So X is, so where X is what? Eigenvector. And this lambda is what? Our eigenvalue. So you can be asked to find the eigenvalues and eigenvectors of any particular square matrix. If you are asked to find that, you are going to find the eigenvalues first. So it is the eigenvalue that will assist you in finding your eigenvectors. Now, what are the steps to follow if you want to find your eigenvalues and eigenvectors? So, the first step is that you have to multiply your lambda by an identity matrix. That's the first one. Multiply this by identity matrix. Number 2, take away the result here from your matrix A, that is A minus lambda I. That is the second step. So the third step is that you find the determinant of whatever you get here. So determinant of A minus lambda I. And the fourth step is that determinant you equate it to be equal to 0. So if you do this, you are going to get your lambda x. You are going to get your eigenvalues. So let's use example to solve that. So example 1. Find eigenvalues and eigenvectors of this matrix 2 minus 1 4 5. So here is what this is 2 by 2 matrix. 2 by 2 matrix. So, and I told you that it is the order of this matrix that will determine the order of your identity matrix. So, solution. So, let A be equal to 2 minus 1, 4, 5. So, that means our high identity matrix is going to be 1 0 0 1. It's also 2 by 2 matrix. So now I told you that the first step is that you multiply lambda, that is the eigenvalue, multiplied by identity matrix. That will be lambda multiplied by 1 0 0 1, which will be use this lambda to multiply all the elements of this identity matrix. That will be lambda multiplied by 1, that is lambda. Lambda multiplied by 0 is 0. Lambda multiplied by 0, 0. Lambda multiplied by 1, lambda. So the second step is you take away the answer gotten from the main matrix A. So I have A minus lambda I to be equal to, my A is 2 minus 1, 4, 5 minus lambda 0, 0, lambda. So here I'm going to get 2 minus lambda minus 1 minus 0, 4 minus 0, 5 minus lambda. So that is step 2. So step 3 here is that I have to find the determinant of these 2 minus lambda minus 1, 4, 5 minus lambda. So I have determinants of A minus lambda I will be determinants of 2 minus lambda, then minus 1 minus 0 is minus 1, 4 minus 0 is 4, then 5 minus lambda. So the determinants here will be the leading diagonal. Here is the leading diagonal. So the elements there, I'm going to multiply them together. So I have 2 minus lambda multiplied by 5 minus lambda. Then minus multiplication of elements, the second diagonal. That will be minus 1 multiplied by 4. So this will give me, let me expand this, 2 multiplied by 5, 10. 2 multiplied by minus lambda, that is minus 2 lambda. minus lambda multiplied by 5 minus 5 lambda. Minus lambda multiplied by lambda is what? Plus lambda squared. Then here I have minus 1 multiplied by 4 minus 4. So I have 10 minus 2 lambda. Okay. Minus lambda, minus 2 lambda minus 5 lambda gives me minus 7 lambda plus lambda squared. Minus multiplied by minus 4, that is plus 4. So here I have 10 plus 4, that is 14, minus 7 lambda, then plus lambda squared. Well, let me rewrite it. So this will be lambda squared minus 7 lambda plus 14. So here is my determinant of A minus lambda I. So step 3. So this one is step 2. Here is step 3. Step 4. My determinant of A minus lambda I have to equate it to be equal to 0. So this will be lambda squared minus 7 lambda plus 14 is equal to 0. So it has led me to a quadratic equation. So we have 3 methods to solve quadratic equation: factorization method, completing the square method, and formula method.